Okay, so what is this chapter about? This chapter is all about young modulus. Okay, so as being stated in the title, so this topic is a young modulus topic. So what do we have in this chapter, in this topic? The main focus would be on what happens to an object when you stretch it. Okay, so we have the first things that we need to know is the stress. So the symbol for stress in this chapter, okay, no, we don't call it stress. We use a symbol for it. So what is a symbol? Okay, what is the symbol for stress? So stress, we use symbol sigma. Okay, so this is a stress. We use it to represent sigma. So basically, it's just like an O and then with a horizontal bar on top of it. So it is F over A. Okay, F over A, the force over the surface area. Now, what is the force and what is the surface area? So provided if you have an object, a rod-like object, okay, so when you stretch it, so the surface area that we are going to look at is the surface area where you have the force acting on it, where the force is perpendicular to it. So when you stretch an object, okay, the force is going towards both end, okay, both directions. So this is the force. So the surface area that is perpendicular to the force, okay, this is what we call surface area, the A that we're going to use in our calculations. So remember, not the area of the whole object, not the area of the whole road, but you're just going to look at the area of the cross-sectional area. So if this is a circle, then it is pi r square. But sometimes questions will give you something that is rectangular. So in that case, you have to use the long time the width of the surface area. Okay, so the surface area is not always circle. That is a common sense misconceptions among students. You guys always thought that surface area must be circle. Not necessary, okay? It could be a rectangular shaped object. It could be a triangle shaped object also, all right? So you look at the object, you look at the directions of the force, and the force is always perpendicular to the surface area. So for example, sometimes you might have an object like this, okay? So you might have an object like this, and then you exert force, okay, you exert force not on the small surface area, not on the side, but you're stretching it on the surface area that is the large one, okay, the large surface area compared to the side. So in this case, the cross-sectional area that we're going to use in our calculation is here. Okay, so this is the A that we're going to use. So A, the cross-sectional area, is a top, okay, on top of the surface. So this is the surface that we're going to use. So make sure you know where is the surface area and what is the force that we're going to use. Okay, now one more thing. When it comes to rod-like object, the force here, usually it refers to tension. Okay, it refers to tensions of the object. So you need to know how to calculate tension, like what you have learned in chapter 4. Okay, so the tensions, if you have a rod-like object or you have a rope. Okay, most of the time in this chapter, we are going to have a rope. We're going to deal with a rope because you're looking at a hanging object. Okay, most of the time, not always correct, but most of the time, if you have a rod or a rod-like object and you stretch it, okay, or sometimes we say you have a wire, then the force that we're going to look at usually is a tension. Okay, we're going to look at the tensions on the actings on the object. So this is a stress. Stress is force over area, and the force that we're going to use most of the time is tension, but not always. And then area is a cross-sectional area. So that is the first thing. So the second thing that we're going to look at is what we call a epsilon. Epsilon is the, okay, oops, it's not L naught, it's the elongations over L naught. All right, it's just a ratio. It tells you how much the object has been stretched. So epsilon over not epsilon, sorry, sigma. Oh yeah, epsilon equals to E over L naught. So what is E? E is the elongation. Now what does it mean by elongation? It's a L final minus L naught over L naught. Okay, so basically you have an object. So this is the original length, and then after you stretch it, it becomes longer. Okay, after you stretch it, it becomes longer. So the additional part is what we call elongation. All right, this is the elongation. So it could be a negative value if you compress an object. Okay, you can compress it or you can stretch it. So in our case, most of the times we have a stretching. Okay, I think we seldom have a compressions in our syllabus. So elongation is the part that extended, okay, that's being extended. So this is epsilon equals to E over L naught. So original length is what we call L naught. So when you combine these two things together, then you are going to obtain a new terms called what? A new terms called Young modulus. Okay, where it tells you the stiffness of the object. So Young modulus is y equals to sigma over epsilon, which is equals to f over a, and then divided by elongations over L naught. So if you rearrange the equations, you are going to obtain an equation that is Young modulus equals to FL over AE. And we are going to use this equation very often in our calculations compared to the other two equations. Okay, so Young modulus, we're going to use it very, very often, right? So the last part we have a strain energy. So that one I'm not going to go through it because it's just from the graph. Okay, the graph of sigma against epsilon. So in this chapter you have a few graph. Okay, that one I will leave it for you. Today I'm just going to focus on how to apply the equations. Okay, how to apply these three equations in solving questions. Okay, now let's look at questions 1. Okay, questions 1. A sign hang a mass, okay, a mass of 1,700 kg is hang from the end of a vertical steel girder with a cross-sectional area of 0.012 m square. So this question is being very nice to use. Straight away, it tells you this is the cross-sectional area. Okay, and then you have a mass here. And then given Young modulus for steel, so Young modulus, it depends on the material. So if you have a steel, then it doesn't matter what is the physical condition, the physical property, then the value would be fixed. Okay, the value is always the same. So basically, you are given a case now, you have an object, a hanging object. Okay, a hanging object. So this object comes with a mass 1,700 kg. So what is a stress? Question is asking for stress. So if you recall, stress is equals to F over A. So like I told you just now, when it comes to stress, most of the time it refers to the strings, okay, the girder. So it's the strings here. So this one, okay, we have a T and then we have a weight. So this object is not moving. If it is not moving, then we have summations F equals to 0. By looking at this diagram, okay, we know that T is equals to W. Therefore, okay, therefore for us, stress, it is equals to mg over A in this case. Okay, it is equals to mg over A in this case. Why? Because the object is not moving, so the tensions acting on this string is equals to the weight of the object. Okay, so it is equals to 1700 times 9.81 divided by the cross-sectional area is given and is already in SI unit. So we have 0.012. Okay, therefore it is equals to 1.39 times 10 to the power of 6 Newton meter negative 2. Because you have F divided by A, the unit for F is Newton, the unit for A is m squared. Okay, the unit for A is m squared. So this is the answer for questions A. So how about questions B? Let's look at questions B. Now questions B is asking for strain. Okay, so how are we going to calculate the strain? So strain, we have epsilon equals to elongations over L naught. But if you look at these questions, you're not given any of these. You're not given elongations. You're not given the original length. So which means this is not the right equations to use. So another equations that we can use to find the strain is Young modulus. Okay, so this is the wrong equation. Therefore, we are going to go for another try, which is y equals to sigma over epsilon. So now can we use these equations to solve it? Obviously we can, because we have already calculated stress in questions A and Young modulus is given. So 20 times 10 to the power of 10. So Pascal is already in SI unit, so you don't have to change it. You just have to make sure your sigma, your stress is also in SI unit, which it is. Okay, Newton meter, they are both SI unit. Therefore, you can straight away plug in the value. So 1.39 times 10 to the power of 6. okay, divided by epsilon, okay, the strain. So strain is then equals to 6.95 times 10 to the power of negative 6 without unit. Okay, without unit. Why? Because if you look at the equations on the right hand side here, elongation divided by L naught. Both of them, they are in meter. Okay, so meter divided by meter. So both a unit, they cancel with each other. Therefore, epsilon is just a ratio. Okay, epsilon is just a ratio. So question C, okay, question C. So if the girder is a 9.5 meter long, how much is it lengthened? So lengthened means elongation. It's asking for the E. Okay, it's asking for the elongation. So how to calculate it? Very simple. So again, you just apply the equation. So for question C, now you can straight away apply epsilon equals to elongations divided by L naught. Okay, so elongation straight away is equal to 6.6 times 10 to the power of negative 5 Newton per meter squared. Okay, Newton per meter squared. So I think the unit here is wrong. Okay, it's just a meter. The unit in your answer is wrong. All right. So elongation is just equal to 6.6 times 10 to the power of negative 5 meter. So that is the answer for questions 1. Okay, questions 1, just a very simple question. You just want to see whether you understand the meanings of every variables in the equations, especially the force. Okay, how to calculate the force. So the force, usually it refers to the force acting on the string-like object, on the part that you stretch it. Okay, so usually it refers to the tension. So now I give you 2 minutes to write it down, okay, including the diagrams on the right hand side, because it shows you, okay, where is the force and where is the area. You need to understand these two things, okay, especially the force and the area, these equations. So elongations and L naught usually isn't an issue in exam, but the issue in exam is students don't know where is the force and where is the cross-sectional area. Okay, so make sure you write down the diagram. You draw the diagram on the right hand side. So I give you 2 minutes to write it down. If you have any questions, you may ask. Okay, so catat diagram, especially diagram di sebelah kanan. Okay, sebab kamu kena tahu di manakah force dia, di manakah area dia. Biasanya kenapa soal pelajar salah chapter ini? Disebabkan dia tak tahu manakah force, manakah area.
Madam,
Yep.
I have a question.
Yeah.
For 1C, you just take the epsilon times with 9.5.
Yes.
Okay.
All right, let's look at questions 2. So a 15 cm long tendon was found to stretch a 3.7 mm by a force of 13.4 Newton. Okay, so the tendon was approximately round with an average diameter. So now this question, it assumes your tendon is a cylinder-like object. Okay, so this is a tendon. Okay, so you have a 15 cm long tendon. So the L node is equals to 15 cm, and then it is being stretched. So the elongation is 3.7 mm. Okay, and then the diameter given is 8.5 mm. Right. So the force acting to stretch it, the force acting on the tendon, okay, that you use to stretch it. So this is the force. So force given is equals to 13.4 Newton. So in this chapter, I encourage you to write down everything first. Why? Because when it comes to chapter 11, usually all these variable they have different unit, because elongation usually just very small. Okay, elongation usually is just very small. So elongations and original length usually they have different unit. So it'll be better idea, okay, it'll be a good idea to write down everything first and then convert everything in SI unit. Okay, change everything into SI unit. So L naught is equals to 0.15 meter, and then elongation is 3.7 times 10 to the power of negative 3 meter. Diameter is equals to 8.5 times 10 to the power of negative 3 meter. Now, the reasons why questions give you diameter is for you to calculate area, okay, where area is equals to pi d square over 4, right? Pi d square over 4. So now that you have all of the informations, you can then calculate Young modulus. So like I told you just now, in this chapter, you will use these equations quite often. Okay, y equals to FL over AE. So is it true? Yes. We are given L naught. Okay, we are given L naught. We are given elongations. We are given diameter for us to calculate the surface area, and then we have force. Okay, therefore Young modulus is then equals to FL naught over pi d square over 4, and then times with E. Okay, so you calculate everything. Okay, I leave it to you. You substitute everything. So you plug it everything. Okay, then eventually you will obtain Young modulus equals to 9.573 times 10 to the power of 6. So the SI unit is Pascal. If you don't want to write Pascal, you can also write it as 9.573 times 10 to the power of 6 and m negative 2. All right, so you have two units. Both are correct. Okay, both are correct. So area, okay, area, let's see. If you calculate the area correctly, you are going to obtain 5.67. Okay, 5.67 times 10 to the power of negative 5 meter square. Kalau anda kira area dengan betul, this is the values that you will obtain. Okay, you will get 5.67 times 10 to the power of negative 5. So done. That is questions number 2. So it's still very short and simple questions. Okay, it's a very straightforward questions. So chapter 11 actually is a bonus mark questions in your exam. Okay, can be considered as a bonus mark questions in your exam. Sangat senang, sangat straightforward. Terus apply, terus dapat. So 1 minute for you to write it down before we proceed to next questions.
Madam,
Yeah.
the area we can actually use pi r square or only have to use pi d square over
Oh,
4.
you can use pi r square over 4. That's fine. Pi d square over 4 is actually coming from pi r square. Okay, because your r is d divided by 2. So when you square when you square d over 2, you obtain d square over 4. So they are
Uh,
the same. So let's move on to the next questions. So this question, it truly tests whether you understand which force to use or not. Okay, so now let's see how to solve these questions. An object of mass 3 times 10 to the power of 3 kg is suspended from a steel cable of length 40 meter. So you are given mass, and then you are given the length, and the cross sections area. Okay, again, you're just given the area. You don't even have to calculate it. So determines the extension. So question is asking for E of the cable when the mass of the system, when the mass of the system mass cable system is at rest, it moves upward with a constant speed, it moves upward with a constant acceleration. So given Young modulus is 2 times 10 to the power of 11 Pascal. Okay, so you have the informations. M equals to 3 times 10 to the power of 3 kg. And then you have a L naught equals to 40 meter. You are given A equals to 1 times 10 to the power of 4 m squared. And then you are given y equals to 2 times 10 to the power of 11 Pascal. Okay, so the object, it looks like this. Okay, so now you have an object, and then you have a steel cable. Okay, you have an object with a steel cable. So this one, it comes with a mass. So questions A. Okay, questions A. Now your object is at rest. So let's sketch a free body diagram for the object first. So this is a free body diagram. So free body diagram, now I have a force, okay, I have a weight that is going downwards because this object comes with a mass, and then I have a tension that is going upwards. Okay, I have a tension that is going upwards. So the force acting on the cable, okay, because if you look at the question, now you are looking at the extensions of the cable. You want the force inside the cable, which refers to the tension inside the cable. Okay, so this is how we determine which force to use. Okay, you look at the force is acting on which object. So what is the force that we're looking at? So for questions A, now your object is at rest. Now, what does it mean at rest? At rest means you're just going to use summations F equals to 0 to determine the values of tension. So T equals to W, which is equals to mg. Okay, so in this case, we have 3 times 10 to the power of 3 times 9.81. Therefore, tension is equals to, okay, tension is equals to, wait, yeah, let me calculate it first. 3,000 times 9.81. So I have a 2.943 times 10 to the power of 4. Okay, 2.943 times 10 to the power of 4 Newton. So this is the answer for tension. So this is a force that we're going to use in questions A. When the object is at rest, it is not moving. So why is it important to know whether object is moving or not? Because it tells us which Newton law to use. So if it is at rest, then we say summations F equals to 0. So from here, we get the tensions. Then we can calculate the extension by using y equals to AL naught over FL naught, not AL naught, sorry, FL naught over AE. Okay, FL naught over AE. So given Young modulus is 2 times 10 to the power of 11 equals to now the force, again, the force, we are going to use tension. Okay, we are going to use tension because it is the force acting on the cable. Okay, this is the force on cable. So therefore, the force is a 2.943 times 10 to the power of 4 times with the original length 40 meter divided by the area 1 times 10 to the power of -4, and then the elongation is the things that we want to calculate. So rearrange equations, you will obtain E equals to 5.89 times 10 to the power of -2 meter. Okay, -2 meter. Now, questions B, you still have the same answer. Why? Because your object is moving at a constant speed. Okay, so if your object is moving at a constant speed, constant speed. Okay. So it means you're still going to use Newton's first law to determine the tension. Okay, therefore questions A and questions B, basically you just repeat the same step. Okay, you repeat the same step and eventually you obtain E equals to 5.89 times 10 to the power of negative 2 meter. So that is your questions B. Now the one that would make a difference is question C. So question C, now I still have an object, the free body diagram, where the tension is going up and the weight is going down. But now your object is moving upwards with an acceleration. A equals to 3 ms negative 2. Now, because your object is moving with an acceleration, we can no longer use Newton's first law. So when it comes to question C, we're going to apply summations F equals to ma to determine the values for tension. So since my object is going up, therefore I'm going to use upward as a positive direction, downward as a negative direction. Okay, so I have a T minus W equals to ma. Okay, so from here you then calculate the values of tension. Right, from here you calculate the values of tension, which is equals to 38430. Okay, 38430. So I'll leave it to you. You try to do it as a revision, see whether you can get this value or not. Okay, 38430. So from here, you then apply the equations of Young modulus, y equals to FL naught over AE. Plug in everything, rearrange equations, you obtain elongation E equals to 7.69 times 10 to the power of negative 2 meter. So this is how you solve it. Okay, this is how you solve it. The difference is on the tension, right? You have a different tension. So question C, your tension is 38430, whereas for questions A and B, the tension is just 2.943 times 10 to the power 4. Okay, to the power 4. So this question is just want to see whether you know which force to use or not. Okay, whether you know how to determine the tension for chapter 11 for Young modulus for the extensions. Okay, so these questions, I give you 2 minutes to write it down, okay, and then make a short notes there. Why questions A, B, and C, they have different answer. What makes the difference? Okay, so the difference is whether you use Newton's first law or Newton's second law to determine the values of tension. Okay, so 2 minutes for you to write it down, and then make sure to make a short notes there so that you understand what is the difference. Now let's look at questions 4. So we are almost done. So as you can see, the question is just very simple, right? So now let's look at questions 4. Questions 4, a wire has a mass of 10 grams. So now you have a mass that is not in SI unit. So the mass is a 10 gram with an original length 2.5 meter. So a force of 100 Newton is applied to the wires and extended by 2.3 mm. So determines the Young modulus of the wire. So again, you see it's just very straightforward questions. So you're given all of the informations needed. You have m equals to 10 gram, which is equals to 10 times 10 to the power of negative 3 kg. And then you have elongation, original length first, which is 2.5 meter, force 100 Newton, elongation 2.3 mm, which is equals to 2.3 times 10 to the power of negative 3 meter. Okay. So a question asking for Young modulus. Okay, so basically straight away you just apply y equals to FL naught over AE. Okay, FL naught over AE. So okay, so the Young modulus. So given the density. So now this question it gives you density. Why? Because we don't have the surface area yet. Okay, we don't have the surface area yet. So now you have a wire. The wire, it looks like this. Okay, it looks like a cylinder. Right, it looks like a cylinder. So you are given rho is equals to 2.7 times 10 to the power of 3 kg m negative 3. Now, in case in an exam you forgot what is the equations for rho, you can actually look at its unit. Okay, units you have kg and m negative 3, which means rho is equals to m divided by v. Okay, volume. Okay, and now since you have questions in both wire, you stretch it. So this is the directions of the force. So what we want is the cross-sectional area here. Okay, we want the cross-sectional area. So how do you calculate the volumes for this cylinder? So volume is actually equals to A times L naught. Okay, so this is your L naught. This is your L naught, and the cross-sectional area is here. Okay, so what we want right now is the cross-sectional area. We want A. So what are we going to do? So expand the equations. M equals to A L naught. Therefore, A is equals to, okay, A is equals to what? It is equals to, yeah, if you rearrange the equations, you obtain 1.48. 1.48 times 10 to the power of negative 6 meter. Okay, you rearrange the equations, you plug in everything, then you obtain 1.48 times 10 to the power of negative 6 meters squared. So this is how you calculate the area, okay, by using density. So first of all, you need to know the shape. So when it comes to wire, usually we treat it as a cylinder shape, okay, cylindrical shape. So cylinder, the volume is equals to A times L naught, the cross-sectional area times the length. So you are given the length 2.5 meter. You are given the mass. So you are given the density. Therefore, you will be able to obtain area. So now that you have everything, you plug it into the equations for Young modulus. Okay, so y is then equals to 100 times 2.5 divided by 1.48 times 10 to the power of negative 6 times 2.3 times 10 to the power of negative 3. Okay, so eventually you will obtain Young modulus. It is equals to 7.34 times 10 to the power of 10 Pascal. Okay, 7.34 times 10 to the power of 10 Pascal. Okay, now questions 2. Okay, questions B. Questions B, strain energy. So what is the equation for strain energy? Strain energy, we have two equations. Okay, strain energy, we have two equations. Yeah. Okay. So questions B. So we have either U equals to 1 over 2. Okay, 1 over 2 FE. Or we have U equals to 1 over 2 sigma epsilon times with the volume. Okay, times with the volume. So you can use either one to calculate the strain energy. And obviously in these questions, okay, the more appropriate equations, the better equation would be the first equations where U equals to 1 over 2 Fe. Okay, so that you don't have to recalculate the epsilon, you don't have to recalculate the values for sigma, you don't have to recalculate the values for the volume. Okay, straight away you can use Fe to solve the questions. So U equals to 1 over 2 Fe equals to 1 over 2. Now F given is 100. Elongations given is a 2.3 times 10 to the power of negative 3. So calculate it, then you obtain 1.115 joule. So that's it. Okay, that is the answer for questions B. Very short and simple. So usually this is a 2 marks question. Okay, a typical 2 marks questions where you need to choose an equations and then you sub the value into that equations and then you solve it. Okay, so find the answer with the right unit. Okay, so this is a typical 2 marks questions. All right, so now I give you 2 minutes to write it down, okay, especially on how to calculate the surface area from density, okay, how to calculate the surface area from density. So this part is important, so make sure to write it down. Okay, so I give you 2 minutes to write it down, then we'll proceed to the last question. Okay, the last questions for today's section. All right. So let's move on to the last question. This question is very similar to the questions that we discussed just now, the question that is moving upwards, moving downwards, and so on. Okay, so you need to determine, okay, you need to determine the tensions by using Newton's law. So an object P of mass 0.5 kg, so you have M, hangs on a vertical tungsten wires of diameter, against your given diameter, and the length of a 1 meter. So you are given the original length L naught. Hanging from the bottoms of P is a copper wire of diameter 0.55 mm and the length of, okay, so now you have 2 wires. Okay, you have 2 wires. So both of them, okay, both of them, they are being joined together. Okay, so an object of mass P hangs on the vertical tungsten wire. From a bottoms of P is another copper wire of diameter 0.5 mm and the length. Okay, so you have another set of information that supports object Q of mass 0.35 kg. Okay, 0.35 kg. So now you have a case like this. This is a wall. Okay, so the vertical tungsten wire, and then object P, and then another wire, copper wire, and object Q. Okay, object Q. So this is the meanings of these questions, okay, of the first statement. So it seems very long, it's a bit complicated, but actually that's it. Okay, that is the meaning. So assume that the elastic limit of the wire is not exceeded and both wires we assume massless. So given Y tungsten equals to 3.6 times 10 to the power of 11 Pascal, Y copper is equals to 1.2 times 10 to the power of 11 Pascal, and G is equals to 9.81. Sketch and label free body diagram for object P and object Q. So for object P, okay, for object P, so what do we have? So if you look at the diagram, okay, if you look at the diagram, object P, it comes with a tension that is going upwards. Okay, so I'm going to call this tension now. It's a tungsten wire with a subscript T. Okay, T with a subscript T to represent this is the tensions inside the tungsten wire. And then there's another tensions at the bottom, but this tension, I'm going to call it TC. Okay, tensions of the copper. So free body diagram for object P is very simple. Now you have an object. Every object, it comes with a weight. I'm going to label it as WP. And then it has a tensions acting on it. Okay, actually you have two tensions acting on it. One is above, one is below. So above you have one tension called TT, and then below you have another tension called TC. So this is the free body diagram for object P. Whereas the free body diagram for object Q, okay, so if you look at what happens in the object Q, now object Q is still an object, so it comes with a weight, WQ. Now the first, okay, the tension acting on object Q is just one, which is TC. So this is TC. So you only have one tension that is going upwards. Okay, one tension is going up. That's it. So that is the answer for questions A. Free body diagram for object P and also the free body diagram for object Q. Okay, so now let's look at questions B. So questions B determines the tension in both wires. So it wants the tensions in a T and it also wants the tensions in a C. Okay, in a copper wire and also in the tungsten wire. So obviously, if you look at the informations given, now I'm going to list down the information first. So the information for tungsten wire, okay, tungsten wire. So I have L node with a small subscript P is equals to 1 meter. And then D for tungsten wire is equals to 0.2 mm. So that is the information for tungsten wire. And then the information for copper wire. Okay, the information for copper wire. I have the length, which is equals to 1.5 meter. And then, okay, and then I have a diameter, which is equals to 0.5 mm. Okay, and then what else do I have? I have the mass. Okay, the mass for object P is equals to 0.5 kg, and then the mass for object Q. Okay, so the mass for object Q. Oh, one more thing that I forgot to write this just now, which is the Young modulus for tungsten and copper. Okay, so Young modulus for tungsten wire, YT is equals to 3.6 times 10 to the power of 11 Pascal. For copper wire, YC is equals to 1.2 times 10 to the power of 11 Pascal. Okay, so the informations, the general informations, the other general information is M P is equals to 0.5 kg, and then MQ is equals to 0.35 kg. Okay, so now we want to determine the tension. if you want to determine the tensions, the information needed is the mass. Okay, it's the mass. Why? Because let's look at the questions A again. Let's look at the free body diagram. So since now my object is not moving, right? So when object is not moving, it means I'm going to apply Newton's first law for both of them. So for object P, if I apply Newton's first law, summations F equal to 0, then I would have T tungsten equals to WP plus TC. Now, obviously, I cannot determine T tungsten straight away, okay, because I only have MP. So T tungsten is equals to MPG plus TC. I don't have TC yet. Okay, I don't have okay, I don't have a TC yet. Therefore, I cannot solve the I cannot calculate TT. Okay, I cannot calculate tension inside tungsten wire yet. So what I can do now, let's try second object. Let's try to look at the free body diagram. So again, I'm going to apply summation F equals to 0 because now both objects, they are not moving. So both of them, okay, both of them, you can solve it by using Newton's first law. Okay, summations F equals 0. So in this case, I have TC equals to WC. WC is equals to MCG. Now MC, I have it. Okay, I have MC just now. So MC is equals to 0.35 times 9.81. So now I have TC, which is equals to 3.43 Newton. So now that I have TC, I can then proceed to calculate TT. Okay, so TT is equals to, now MP, I have MP equals to 0.5 times 9.81 plus 3.43. Okay, so from here I then obtain the value that is equals to 8.34 Newton. So that is the tension inside tungsten wire. Okay, tension inside tungsten wire. So that is how we solve it, right? So now I give you, okay, I give you 2 minutes to write it down first before we proceed to the next questions. Okay, the strain energy. You need to understand this part first. Okay, you need to understand this part. This part is actually the revision for chapter 4. Okay, part ini dia actually revisions untuk chapter 4 saja. So kamu tengok dulu. Okay, kalau boleh. Okay, then kita akan solve questions B2. Okay, questions B2. So pastikan anda faham yang ini dulu. Okay, so yang ini alright kan? So now let's see. So now that you have tensions, so I'm going to put it on the here. So tungsten, I add in one more piece of information right now. So I have T equals to 8.34 Newton. And then for copper, I have Tc equals to 3.43 Newton. Okay, so now that I have two complete set of information, so why is it so important to know which information belongs to which object? Because you need to use them to calculate the elongation. Okay, the elongation is in the extensions, in the tungsten wire and also in the copper wire. Okay, in order to find out what is the total strain energy. So what does it mean by total strain energy? Total strain energy is U total would be equals to U tungsten plus U for the copper wire. Okay, U for the copper wire. So now let's see how are we going to solve it. Okay, so when we say total energy means you just add all of the energy together. That is the meanings of total energy. Okay, regardless of what is the object that you're looking at. You can have different object. As long as they are inside the same system, if the question asks you to calculate the total energy, then you have to add up the energy from all of them. Okay, from all of them. So that is the meaning. So U total equals to UT plus UC. So UT is equals to 1 over 2. Okay, now since we say FE, right? So FT and then elongations in the tungsten wire plus 1 over 2 FC elongation inside copper wire. So the informations that we don't have right now is the elongation. We have the force already. Okay, the force is the tension in the from questions 1 just now. Okay, from questions B to 1. So B1, sorry, from questions B1. So we have the answer from questions B1. Okay, which is the force, the FT and also the FC already. So basically they refer to the same thing. Okay, they mean the same thing. So TC, TT sama dengan FC dengan FT. Alright, they are the same actually. So now the things that is missing is the elongation. Okay, but you can calculate elongation by using Young modulus questions. Okay, Young modulus equations. Because now you have initial length, you have the diameter, which can then be used to calculate the area, and then you have the Young modulus, and also you have the force. Okay, so for tungsten, let's calculate the elongation first. Okay, let us calculate the elongation for tungsten. So elongation for tungsten. Now we apply Young modulus equation. Y equals to FL naught over. Now since we're given diameter, so pi d square over 4 times with the elongation. Okay, times with the elongation. So you plug in everything. Eventually, you will obtain E for tungsten wire is equals to 6.09 times 10 to the power of negative 4 meter. Okay, 6.09 times 10 to the power of negative 4 meter. So I'll leave it to you. You try to plug in everything and see whether you can get ET or not. Okay, and then for copper wire, again, we are going to apply the same equations because you are given same information. So FL naught and then pi d square over 4 times E. So if you calculate, it correctly, you will obtain, 2.18 times 10 to the power of negative 4 meter. Okay, times 10 to the power of negative 4 meter. So that is how you solve it. Okay, that is how you calculate the elongation. So now that you have elongation, and then you also have the T, you can then proceed to solving the questions. Okay, so plug in everything. So I will have 1 over 2. So FT is 8.34 times elongation, 6.09 times 10 to the power of negative 4, and then plus 1 over 2, 3.43 times 2.18 times 10 to the power of negative 4. So the final answer is equals to 2.91 times 10 to the power of negative 3 joule. Okay, so that is how you solve it. So in exam, it is always a good idea to list down the information first so that you know which information belongs to tungsten wire, which information belongs to copper wire. Okay, you cannot mix them up. If you mix it up, then you will get the wrong answer. Okay, so sentiasa asingkan maklumat, ikut bahan yang diberi. Okay, it is always a good idea to split the information according to the materials given, according to the objects given, so that you know what is the information that you have, you know what is the information that to be used to calculate the things that you need. Alright, the other information that you need. So kalau kamu tak list down, actually you won't be able to see that you can actually calculate the elongation. Okay, kalau kamu tak list down, dia ikut cara yang saya buat ini, okay, ada pelajar dia tak nampak. Sebenarnya dia ada maklumat yang mencukupi untuk kira elongation sudah. Sebab ada L naught, ada D, ada Young modulus, ada tension. Okay, so you have everything needed to calculate elongation. So kalau kamu tak list down, memang tak nampak. Right? So I think that's all. Okay, that's all for today. That marks the end for today's class. We are done with chapter 11. So chapter 11, we have only 5 questions. Okay, so now we are done. You may try the past year questions in your Telegram. Okay, so you may start trying the past year question as a preparation for your exam. Jangan tunggu sampai exam baru nak cuba kamu punya past year. Okay, dia tak akan sempat punya. So try past year questions. Okay, because exam usually they will have quite a lot of past year questions. Okay, they